Hello Year 11. Copper comes up a fair few times in the GCSE specification. We're going to concentrate on copper in this session, in particular focusing on how copper is extracted from both its high-grade ores, very briefly, and then a bit more time on bioleaching and phytomining, which is extraction of copper from low-grade ores. And we'll do a little overview of other places that copper is involved in the specification later on. So the first thing is let's make sure we know what we mean by ore. So an ore is rock containing sufficient copper compounds, so compounds of copper, so copper oxide, copper sulfide, or some other copper compound, or metal compound, in this case copper, to be kind of worth extracting financially. Right, so how much copper is in a rock will determine whether it's worth getting any copper out of it. And you need to know that if you've got rock that contains a significant amount of copper, you can extract the copper from it and make yourself a load of money. So the first way of doing that is using high-grade copper ores. And these are becoming more scarce, but they still exist and are still the main way that copper is produced from its ore. So you don't need to know very much about this at all. So one is that you simply would add acid to the copper compound, and that might be, for example, copper oxide. And if you add acid to copper oxide, you know that you would get copper sulfate solution. And we're going to talk about how we get the copper from the copper sulfate solution in a bit. But I kind of wanted to raise that now because this becomes important later on. So copper sulfate, that blue solution that you've seen. Another way of getting copper from its ores is through a process called smelting. It's really quite a complex process that I've simplified here, but essentially you take a particular copper compound, so a compound that involves, for example, copper, iron and sulfur, and it goes through a number of processes, one of which will be taking copper sulfide and turning it into copper through this reaction. But all you need to know is that there is a process called smelting, and that it's quite fast, it's quite expensive, it requires lots of energy, and that has therefore quite a large environmental impact. And mining those copper compounds from the ground obviously produces environmental damage as well. So be aware that this topic does involve some evaluation, some comparison of different methods of extracting copper. And they like this idea in the GCSE, comparing two ways of doing things and evaluating those two methods. So the environmental impact, the speed and the cost and energy cost are some things that we'll consider. But if you've got low-grade ore, which means it's got a much lower percentage of copper in that rock or that soil, then you can use two modern approaches for extracting the copper. So you can't use the methods we talked about above because there's simply not enough copper in the soil. So you could use phytomining, which we'll talk about that in a second, or something called bioleaching. They both end up making what we call a leachate. Okay, so in other words, again, just like before, a solution of copper sulfate, and we'll talk in a moment about how we extract the copper from that. Now the process of phytomining involves taking some soil that has got some copper on it. It might be waste materials from where copper was once mined, but then you grow plants on it. So step one is grow plants. And the word phytomining has got a P at the start of it, so phytomining, think plants. And if you need to know a little bit more, it's usually cabbages that they grow. And what happens is the copper ions in the soil, so copper 2+ ions in the soil, travel up through the roots and end up in the leaves. Right, so the copper 2+ ends up in the leaves. So the leaves are kind of a concentrated, slightly more concentrated form of the copper now. What you then do is you wait for the plants to finish growing and you burn them. And the leaves will contain atoms of hydrogen and carbon, a few other things, but also the copper. Now the hydrogen and the carbon will burn and be released as carbon dioxide and water. So they'll be gone and be left essentially with copper oxide in the leaves, so sort of much more concentrated solid copper powder essentially. Yes, it'll have other bits and pieces in there in the ash, but it's got a much higher now concentration of copper than you had in the soil in the first place. Then you take those copper compounds in the leaves, and again I keep making the point that they're compounds rather than pure copper. It's an ion of copper, an ionic compound of copper, and then you add acid again. Again, this will be sulfuric acid, H2SO4, and you end up with copper sulfate. And there it is. You end up with copper sulfate to get to the leachate there. And bioleaching, which starts with the letter B, is using some sort of special bacteria. Now, you don't need to know much about what's going on there, but essentially the bacteria chomp away on the copper compounds, and they end up producing a leachate. So you can think of the bacteria as kind of feeding on the energy in the bonds, if you like. And we're going to talk about in a moment about how we extract the copper from the leachate. But in terms of the evaluation of the methods of getting copper from high-grade ore versus low-grade ore, we sort of end up in the same place. But the advantage of the low-grade ore method, the phytomining and the bioleaching, is there's much lower environmental impact. So there's not much heating involved, there's not much mining involved, so there's less energy costs. The problem is that it's much, much slower, and that therefore takes time, and there's issues associated with producing large quantities. So as with everything, there's advantages and disadvantages. So how do you get the copper from the leachate? So you've got a copper solution, and you can do one of two things, and you need to know them both. So one method is taking the copper solution and simply adding scrap iron to it. So a scrap iron is really cheap compared to copper. There's lots of scrap iron from used cars or whatever, and so you put the scrap iron into the copper solution, and you get a displacement reaction going on. So it's a redox reaction, and you end up with iron sulfate solution and copper solid. That copper might not be that pure and could be purified, and we'll talk about how that's done in a second. But the other way is simply doing electrolysis. So electrolysis is taking copper ions that are in solution and reducing them, so gaining electrons. Now, I did a whole session, after school session, on redox, where I talked about electrolysis to produce aluminium. Same sort of idea, really. So if you need more guidance on this, have a look back at that. But essentially taking the electrolysis setup, having copper ions in solution, so very, very briefly, copper ions in solution, you've got electrolysis going on, got a positive electrode and negative electrode. Copper ions will travel to the negative electrode, which is of course negative because it's full of electrons, or electrons being pushed towards it, and there's a reduction takes place. So copper ions travel to the electrode and turn into copper metal. Right, so they're the two methods. One is displacement, and the other is electrolysis. Now in the textbook, though not in the revision guide, it does say something about how the copper here is purified by electrolysis as well. I'm not convinced you need to know about this, but very briefly, just in case. So what you would do is you'd take, instead of having carbon graphite electrodes, if you have copper electrodes, we call active electrodes, so copper and copper. Over here, just like before, copper ions that are in solution travel to the cathode, the negative electrode, and become pure copper through reduction. But over here, the impure copper, which is actually the electrode now rather than carbon, the impure copper, which has maybe got all sorts of other impurities in there, is turning into copper ions. And they then travel across, they turn into copper ions, which travel across and become, so they get oxidized to copper ions and then go over here and then reduce to copper atoms again. So you can use electrolysis to purify copper too. There's a little bit on the textbook in there if you want to to read up on it on your return. It's worth also saying that copper appears a few other times in the specification, so I've made a couple of notes just to remind you. So copper appears, you need to know the flame test approach for testing for copper, and you get then a green flame. You need to know the other test for copper, which is the precipitation test with sodium hydroxide, and you get a blue precipitate. PPTE is your shorthand for precipitate. You need to know that the copper oxide comes up in the method of making a soluble salt. So you take copper oxide, add it with sulfuric acid. This is one of the core practicals, isn't it? You make copper sulfate. Remember all that stuff about filtering off and reducing half the volume to increase the concentration and grow crystals. You need to know the alloys of copper, which are bronze and brass. So bronze is copper and tin. Bronze is copper and tin, and brass is copper and zinc. Find a way of remembering that. Here are some daft ways of remembering. For me, one way it could be that bronze has got the letters Z and N in it the wrong way around, so it's definitely not the one that's got zinc. Maybe that's one way of doing it. One that works for me is that I know zinc is kind of shiny, I know brass is kind of shiny. That works. That's the one that works for me. That's how I remember it. Another way could be that imagine a brass zinc. That sounds really stupid, but just imagine a sink made of brass. That could help you remember. Find a way of remembering which one is which, because you're expected to know that. And also some uses of brass and bronze, armour, for example, and decorative things around your house, maybe door handles, for example. And also you need to know that copper is unreactive in acid, because copper is very low on the reactivity series. That's it. Cheers. Bye.